Dear students, Assalamu alaikum. I am Sabeen Amjad. I am going to teach you software testing. Before starting our next topic, let's we have a look at the topics that we have already covered. Introduction to software testing, motivational stories for software testing principles or axioms, test cases, test procedure, software testing life cycle, V model, modified V model, then test-driven development, software testing process, and software test plan. And the topic for today is performance testing. Let's have a look at the outline of the topic. I have divided it into two parts. In the first part, we will cover performance testing objectives, then performance testing introduction, types of performance testing, factors governing performance testing, and in the part 2, we will cover methodology for performance testing and tools for performance testing. Performance testing objectives. We have the following performance testing objectives: to detect and prevent failures of software system before it comes into commercial use, to determine the maximum number of simultaneously users that the system can allow, to determine the max number of concurrent transactions being executed at the server per time unit without sacrificing the quality of service. Now the question is what we want to achieve through performance testing. Obviously, high speed, scalability, and stability. Now, what is scalability? Scalability is the ability of the system to scale up or scale down the number of user requests. For example, a system may run very well with only 1000 concurrent users. But how would it run with 10,000 users? And hence the stability of the system will also be checked. Now, what is stability? Stability means software performance under specified conditions for a stated time period or for a certain number of operations. We check the performance of the system in these circumstances. Performance testing introduction. In software engineering, performance testing is a practice performed to determine how a system performs in terms of responsiveness and stability under a particular workload. This is the definition of performance testing. It can also serve to investigate, measure, validate, or verify other quality attributes of the system, such as scalability, reliability, and resource usage. Scalability, I have already told about this, and now the reliability. Here, reliability means how much the system fails in a specified time duration, or you can say how many failure-free operations a system performs for a specified time period, and this is the vice versa. Resource usage means do the processor, memory, internet, and other resources of this type return back to the pre-test level as the performance testing ends. Now we will come to the topic types of performance testing. First is the load test. Load test mean to stimulate the maximum use of the system. We must analyze the number of users that will have access, the operations that will be executed. Here in load test, we apply load on the system mentioned in the requirements. For example, your NFR says the system shall allow 500 users to generate their result card at a time. Let's say when the result declaration date is announced and a lot of users sign in the system and try to get their result cards. So the requirement is 500 users. For load testing, we will generate load of 500 users through simulators to generate result card and check the system behavior and its response time. The graph in this slide shows increase in the load, then a constant load for some specified time duration, and then decrease in the load that we will the load will be decreased to stop when we will stop the testing. Then comes the stress test. The purpose is to find the stepping up breaking point. It is achieved by executing the most accessed transactions in an incremental manner until the system fails. It can also be achieved by increasing the number of users that the system can support with the infrastructure in which it is installed. So, there are two ways to increase the load on the system. First is the executing most access transactions, and the other is increasing the number of users. In stress test, it is also noteworthy that how long it takes to recover regular functioning after the system has been down for a period. When when breaking point comes, the system will be down, but system will be efficient. It will recover as soon as possible to the pre-test level. As you can see in the graph, there is a continuous increase in the number of virtual users. Let's consider the previous example, where 5 users simultaneously access the system for stress test. First, we will add 50 users and then test the system. Then we will add more 50 users and again test the system. We will repeat the same pattern until the system breaks. Then is endurance test, mean to test the system during longer periods of time in order to reveal other types of problems. It may result in increased number of problems, for example in case of a memory leak. Analyze the system's behavior following a specific period in operation. For example, 500 users access the system for a longer period, let's say for 5 hours. During this period, we will also observe the behavior of other resources. For example, memory, processor, and internet connection. At the end, when load is decreased, the resources should also be released. Same is represented in the graph. Throttle test. A simulation of the load with limited speed of connection of users to analyze the response time. Here we have limited speed of internet connection, but the load on the system is according to requirements. Speed simulators or traffic shapers are used in these tests. So we have speed simulators and traffic shapers which can increase usable bandwidth for some kind of packets by delaying other kinds of packets in the network, of course. Peak test. To analyze the system's behavior when exposed to intensity peaks mixed with the regular load. It shows the recovery after the increased load. Here we apply mixed load on the system. Load on the system is sometimes increased and sometimes decreased. The resources should also be released when load is decreased. Different types of load patterns are shown in the graph. Then is scalability test. It analyzes that how system escalates. It indicates, for example, how many more users we can support if another application server is added. Improvements in timing when we add more CPU to the database server. Next is factors governing performance testing, and it includes throughput, response time, tuning, competitive analysis or benchmarking, resource availability or capacity planning. First is throughput. The capacity of the system or the product in handling multiple transactions is called throughput. Number of requests or business transactions processed by the product in a specified time duration. The throughput varies according to the load the product is subjected to. The optimum throughput is represented by the saturation point, that is maximum throughput. The load to the product can be increased by increasing the number of users or increasing the number of concurrent operations of the product. The graph in this slide shows initially the throughput keeps increasing as the user's load increases. This is the ideal situation for any product. In the second part of the graph, it can be noticed that the throughput comes down. This is the period when the users of the system notice a lack of satisfactory response and the system starts taking more time to complete the business transactions. The optimum throughput is represented by the saturation point. Response time. The delay between the point of request and the first response from the product. In a client-server environment, throughput represents the number of transactions that can be handled by the server, whereas response time represents the delay between the request and response. Not all the delays between the request and the response are caused by products. Some delays are due to product, while others may be due to environment. Latency is a delay caused by the application, operating system, and by the environment that are calculated separately. Let's have an example. The client sends request to the web server through network. The delay that can occur is N1 due to the network resources. The application deployed at the web server processes request and that delay is represented by A1. Web server sends request to the database server through network. The delay that occurs due to network is N2. Database server processes the request and the delay between query request and query response is A2. The query response is sent back to the web server through network. The delay that can occur is N3. The web application at the web server processes the response and the delay at the web server is A3. The response is sent back to the client through network. The delay that occurs due to the network is N4. Now in the example, latency and response time can be calculated as network latency is equal to N1 plus N2 plus N3 plus N4, whereas product latency can be calculated as A1 plus A2 plus A3. Actual response time is equal to network latency plus product latency, means sum of both types of latencies. Any improvement that is done in the product can only reduce the response time by the improvements made in A1, A2 and A3. It means product latencies, to reduce the product latencies. If the network latency is more relative to the product latency, in such case it will be worthwhile looking at improving the network infrastructure. Now before explaining the tuning in the terms of software products, consider the example of the tuning of car engine. For tuning purpose, you do not open the whole engine. You just do some fuel adjustments, cleaning the filters, check water level and engine oil level, and so on. In the same way, product tuning is a procedure by which product performance is enhanced by setting different values to the parameters of the product, operating system, and other components. Tuning improves performance without touching the source code of the product. Product parameter or variable values need to be changed to get optimum performance for a particular configuration. So we do not look into the code, we just change the values that we are passing to the product. Competitive analysis or benchmarking. Here we do comparison of the similar products available in the market. Performance testing where throughput and response time of competitive products are compared. It is not easy to decide which parameters must be compared. No two products are same in features, cost, functionality. Careful analysis is required to chalk out list of transactions to be compared. This analysis will improve performance of the product. Keep in mind all features are not comparable because no two products are not 100% same. We have to identify the comparable features to do this analysis. Resource availability or capacity planning. The exercise to find out what resources and configurations are needed. The purpose is to help customers plan for the set of hardware and software resources prior to installation or upgradation of the product. Remember, during tuning, we identify both the hardware and software resources, their versions, and capacities at which the product performs best. Same is communicated to the client so that he can arrange for those resources, for example, processor and memory requirements at which products performs best. So here are the references for you. If you do not understand any concept, you can consult this book, and for question answer we will have a session, of course. Thank you. Take care, students. Allah Hafiz.